All right, good night to everyone who's joined us early. We're going to try to start this marathon on time. And of course, just to give you purpose of tonight and how we're going to be functioning tonight for this marathon. Now, I'm going to be looking at paper two, as I said, focusing on paper two. That will be, of course, we'll be looking at 2019 past paper. Tonight. I'm not sure if we'll be able to do another one, but hopefully we can. Now, the procedure for tonight, I was hoping that I'd have some students in Zoom tonight, but they have not yet joined me. I'm not sure if they're available for tonight, but the exam is on Wednesday, so let us start tonight and see what can happen for tomorrow. Of course, tonight is not really for you to work it out and give me an answer. It's just to see how you'd approach the question. Because getting the answer is one, but if you're not sure how to approach the question, if you're not sure how to read and understand what you're being asked to do, then naturally you will not get the correct answer. Makes sense to you, right? So therefore, for tonight's experience, for the exam, you are given 60 minutes to complete each question in the exam, because of course you have 1 hour, sorry, 2 hours. It's actually about, I think it's 2 hours and 40 minutes thereabout. And of course, you're given 60 minutes to, well, an hour and 60 minutes rather. So you're given 16 minutes to complete 160 minutes, sorry, 160 minutes you are given. So with that 160 minutes, you are expected, in 10 questions, you're expected to spend no more than 60 minutes on each question. So to ensure that you do not go over a question over and over and over, we're looking at techniques that you need to use to go through each question and how to approach each question so that you can have a fighting chance of passing your exams. Now, of course, some of my students in Zoom, the CDPLABS, I should say, were given multiple choice papers to do. We have another half to complete. For those who did not do so well in those multiple choice questions, turn up for 8 o'clock class tomorrow so we can go through those questions that we did not do so well on. So we're going to be starting at the back of the exam tonight. So therefore, that will be vectors and matrices. Then we go from vectors and matrices to, we probably look at some of the algebra and regions and functions, but better yet, we're going to be looking at circle theorem, of course, in trigonometry part of it. And of course, so we take it from the back to the top. And remember now, we'll be given 16 minutes to try to complete each question. But being that our students in Zoom are not on, then we're going to just proceed to giving a few minutes to complete each question, and then I'll take it from there. All right. Now, before we're going to start with CDPLABS style, we like to, of course, invite our maker and king in our midst. So just going to ask you to sit back, relax, and listen to this devotional song, and then I'll pray and ask God's blessings to be on the session tonight, because I cannot teach without him, because through him, I'm able to do the best I can. So stay tuned for paper 2, 2019.
I love you, Lord. Oh, your mercy never fails me. And all my days I've been held in your hand. From the moment that I wake up until I lay my head, oh, I will sing of the goodness of God. 'Cause all my life you have been faithful, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. I love your voice. You will lead me through the fire, and in darkest night, you were close like no other. I've known you as a father, I've known you as a friend, and I have lived in the goodness of God. Yeah. And all my life you have been faithful. Oh, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. Yeah. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running, it keeps running after me. And all my life you have been faithful, and all my life you have been so, so good. With every breath that I am able, oh, I'm gonna sing of the goodness of God. I'm gonna sing, I'm gonna sing. Oh, 'cause all my life you have been faithful, and all my life you have been so, so good. With every breath that I am able, oh, I'm gonna sing of the goodness of God. Oh, I'm gonna sing of the goodness of God. With every breath, oh, for all my days.
Okay, so let us give God thanks for the goodness, for His goodness, for, of course, following us throughout our lives. And before I pray, I just want to say to you that um, if I perform well tonight and you perform well in the exam, it is not anything that I have done, but it's through the goodness of God has done. But I also just like to go through tonight's session that you pray for me as well. I mean, Makeda, good night, Tanisha, we know, good night. Of course, Makeda, my mind is in a good place tonight, so Yes, I'm ready to work for tonight. But still pray me up so that I can get this job done tonight. So let us pray and then get ready now to put on your thinking caps so that we can have a good session tonight. Let us pray. Our Father who art in heaven, hallowed be your name. Just want to give you thanks, dear Lord, for sparing our lives to live to see the night's night now. As we're about to prepare for the exams coming on Wednesday, we know that we can do all things through Christ who strengthens us. We know, dear Lord, that you have said that we delight in you. You give us the desires of our hearts. Father, as we come before you, knowing that we cannot do this of our own, we ask that you will lead out tonight's session. Pray, oh God, that you will be with each and every student watching from the YouTube channel and those who may join us live on Zoom. But for every student who are preparing for exam, locally and abroad, may your name be glorified throughout this last moment in preparation. Father, we know that you can do it. You're an on-time God. When Lazarus died, when you were late, some person saw it that you were late for Lazarus. But dear God, you're an on-time God. So even though they might think that time is short, but with you, there is no such thing but readiness and preparedness to be ready for exams. So take it away tonight, dear Lord. Forgive us now for our sins. Now we have trespassed against thee, as we forgive those who have trespassed against us. In Jesus' name we pray. Amen. All right, so good night again. Um, Welcome to those persons on our YouTube channel. Um, this CDP Labs services is normally a very interactive session that we have. We didn't get to do much interactive interaction like last year, but certainly coming up back for the human and social biology exam, which we got 100% pass, definitely we are coming back with that again. I'll be prepared to bring back that for HSB. But tonight is mathematics. We're speaking about mathematics tonight. And of course, get out your pencils, get out your pen, your rulers, your geometry set, your calculators, get your water. Walk around if you feel like you want to sleep, because tonight we're going through some questions tonight. So if you feel like you want to sleep, get walk up and down and come back again and just take it away tonight. So tonight is your last Saturday night before we get the maths exam on Wednesday. So we want to personally turn to our first question tonight. And of course, let's see what's up for tonight, right? So we're going to look at our first question for tonight. Um, we said we're looking at it. Maybe some of you might have done the question before, but we're going to look at what we should use and how we're going to be using it. All right. So our first question tonight comes from 2019 paper, question number 10 on vectors and matrices. And you must practice, because practice makes perfect. All right. So hope you can see the screen. You can see the screen. All right. If you're able to see the screen. All right. So first question says, find the matrix product. So when you're approaching the exam question, look at the words given in the instruction. A lot of students, they tend not to follow instructions, and that is their downfall most of the time. You must follow instructions. If you don't follow instructions, you're going to get yourself in deep waters. So it says find the matrix product. And if you notice something here, the word product right here. So the word product, when you see the word product, and I'm asking the questions because I want persons in the YouTube chat to give their response in the chat. It says find the matrix product. What is that? What is that word indicating to you? Find the matrix product. What is it exactly asking you to do? When you see the word product, what is it asking you to do? I see 4 persons watching us live on YouTube. If you have not yet subscribed to our channel and you want to interact with us, then you have to subscribe to the channel. And in 5 minutes, you'll be able to send your messages. So if you have not yet subscribed to the channel, go ahead and subscribe to the channel so that you'll be able to participate in using the chat. So what does the word product in the instruction suggest to you? The word product, what does it suggest to you? I want my persons in the YouTube to give me an answer. What does the word product suggest to you? Waiting for an answer. What does the word product suggest to you? See the word product, what does it suggest to you? Now, there are some problem solving, there's a problem solving guide I want to share with you as well, that this is a problem that you have to solve. And you have to explore the problem. And when we're talking about exploring the problem, all right, I see Makeda gave me the response, it means to multiply. Good, means to multiply. So before I get back to that, Makeda, let me just share a few little things with you guys. You have to explore the problem. Good. What do we mean by exploring the problem? We mean that we're going to find what and who the question is asking for. So you have to find out what the question is asking for. That's why I told you, if you see the word product, what comes to mind if you see the word product? So we have one of our students just joining us, that is Lexi. So we want to know what does the word product is asking you to do. And as Makeda rightly says, to multiply, right? So we're going to be multiplying. So they're asking, so whatever is in front of you, you must multiply. Now, just see if you were watching the night lecture. It's 9:22. We should have started at 9 o'clock. Why it took so long to come. But anyway. All right. Now, after you have explored the problem, then you're going to plan. What do we mean by planning? How will you arrive at the answer? So now we're looking at this matrix here, and it says multiply. So obviously they're talking about multiplying matrix. Now, what are the steps to multiply matrix? That is the question we're asking ourselves here. What are the steps to multiply matrix? How do we multiply matrix? How do we multiply matrix? Of course, to multiply the matrix, matrix multiplication, we're going to multiply a row, multiply row by column. That's how we do it. So that's our plan. Multiply row by column. So you must be able to identify what is the row, right? What is the row? Now, of course, a row is horizontal. So there are two rows right here in this matrix here. And this one is called a 2 by 2 matrix, of course. It has two rows and it has two columns. Now, this one is called a column matrix. Because it has one column. Well, it is not really a column matrix, but it has one column. It's a column matrix actually. Good. But you have two rows in it. Good, but one column. There's 2 by 1. All right. So when you're multiplying the matrix, of course, you're going to multiply a row by column. By column. Let's see how that is done. How do we multiply a row by column now? So of course, let's rewrite it. So we have -1, 4, 3, and h. Multiply it by k over 5. Now, all it asks is to find the matrix product. So row by column simply means -1, you have to multiply by the corresponding elements. So the first element in this row multiply by the first element in this column. So you have 1k, let's say it is -k, then 3 times, so add, 3 times 5 is 15. Then now, second row by the same column, 4 times k will be 4k, and then h times 5, which is 5h. And that's the answer. Simple. So all of this is the answer. So -k plus 15, 4k plus 5h. And that's the answer for the first one. So the word product then tells us that we're going to what? Multiply. Right? Good. Now, the other part of the problem solving guide tells us that we are to carry out the plan. So what I just did, I identified the plan, and the plan is to multiply the matrix row by column, and I carried out that plan. Now, of course, we must examine our solution. What does that mean? Check to prove if your answer makes sense. Now, students, for your answer to make sense, you'd have been practicing from your textbook. I always tell my students, practice from the textbook. He who listens is wise. He who fails to listen is foolish. And if you do foolish things, don't expect to get the reward of a wise person. All right. So we're going to move on now. Lexi, did you get that, Lexi? Huh? I don't hear that.
Repeat that for me.
Did you get the answer for this one?
Yes.
Okay. All right. So that was just 2 marks. We're going to go to the second part. It says, hence find the values of h and k. Hence. Now the word hence suggests that it's a transitional word, which simply means that whatever you did in part A is corresponding with part B. Now you have to be very observant, students. You have to be very observant. If you look clearly right here and clearly right here, it's the same thing. So you don't need to be going through the same thing over and over. You're just using the same equation that we formed a while ago and then set it equal to 0. So you're going to find the values of h and k that satisfy the matrix equation. What do they mean, satisfy the matrix equation? What do they mean by that? That's what you need to ask yourself. What do they mean by satisfying the matrix equation? What do they mean by that? Of course, let us write about the matrix. Let's write about the matrix. Write it back. We'll write about the matrix right now. So let's wait a minute. So we can bring up all right, so we're going to be going back to that matrix question right now. All right, so hope you were following earlier. So of course, what we had earlier, let's use this one instead. So we had -k plus 15 and 4k, was it negative 4k? It was 4k, it was 4k plus 5h. So we're to set this now equal to 0, 0. Now, when you look at this, what comes to mind? What comes to mind when you look at this? What comes to mind when you look at this? What comes to mind? Okay. What should come to mind is what we call equal matrix. Good, because the equal sign, it is telling us that this matrix is equal to this matrix here. So if you notice this row, the first row at the top right here, should correspond with the row at the top in this matrix. So let's call this A. Let's call this B. Good. So in matrix A, row 1 must correspond with row B. So row 1 in matrix B. And row 2 must correspond with row 2 in matrix B. So let's look at it now. So negative K plus 15 is equal to 0. It's equal to 0, right? So then, the question is then, and I normally tell my students to ask themselves questions. What number, when added to 15, is equal to 0? Now, it is evident that if K is equal to, what would K be equal to? Negative of what plus 15 equal to 0? Please bear these tricks in mind. Negative 1 plus 1 is equal to 0. Right, Lexi? Right, Lexi? Negative 2 plus 2
Yes, sir.
is also equal to 0. Negative 3 plus 3 is also equal to 0. Negative 4 plus 4 is also equal to 0. Now you might be asking, how can I prove that? All right, simple. Let's use negative 3 plus 3. So you have negative 1, comma, negative 1, comma, negative 1, comma. These are 3 negative ones. And it's 3 negative 3. So we're going to have the positive ones. Positive 1 plus positive 1 plus positive 1. The commas, separate them. The negative 1 cancel one of the positive ones. Negative 1 cancel another positive ones. Negative 1 cancel another positive one. So therefore, what you end up getting is that there's nothing left. It's clearly 0. All right, I see your answer there, Makeda. You said negative 15. But is the answer negative 15? Is the answer negative 15? That is the question. Is the answer negative 15? All right, so Makeda have negative 15 plus 50. Well, so what is the value of K then? Next thought, that the same. All right, but what is the value of K itself? Is K negative 15? Is it negative 15? What's the value of K itself?
Negative 15.
No, cannot be negative 15. Because if you say negative 15, you want to say when I substitute, when I put it like this, I put negative 15 right here, what is going to happen? Become positive, right? So it cannot be negative 15. See? It is actually positive 15 and not negative 15. Like that now?
Mhm.
K is actually positive 15 and not negative 15. Here it is. So it will be K, negative K equal to negative 15. Because when you carry over the 15, it becomes minus 15.
Mr. Wade. Mr. Wade.
Yes, it divide now both sides by negative 1. And therefore, K becomes positive 15. You have to be careful, right? Good. So now that we find the value of K, we can now go to the second equation and find the value of H, right? So let's go to that now. Right. So we know the value of K. I'm sorry about that. We know the value of K. Let me erase this first. The value of so 4 now times 15 plus 5H is equal to 0. Good. So 4 times 15 is 60 plus 5H is equal to 0. Now 60 plus what will give us 0? That's the question. What number when added to 60 give us 0? Answer.
Negative 60.
Negative 60. That simply means that 5H must be equal to negative 60, right? So let's write 5H equal to negative 60. Now note something. If you question the thing like that, there's no need to go to the next step. You just right away use your common sense and know that 5H then must be equal to negative 60. So even if you weren't taught what you should do with the 60, when you go with the equal sign, if you use your common sense, cannot go wrong. Make sense?
Yes, sir.
Right. So what times 5, what number when multiplied by 5 will give me negative 60? What number when multiplied by 5 will give us negative 60? You have the answer. But then you
Negative 12.
negative 12, that's correct. So H then is negative 12. Simple. Save time. So questioning the thing like that, save us what? Time. All right? So at least you learn a method how to save time. So you question it like that, of course, you'll be good to go. Now, before I go into another part of the question, there's a thing that we need to look at as well. So let me close the whiteboard. Go to another part of the question. Right here. Gonna go to another part of the question. Quickly. Now there's a justification guide that we need to pay attention to when justifying. Good. Trying to quickly get back to the question here. Okay. So we found both the value of h and the value of k. So k is, we found that k is positive 15, and we found that h is negative 12. So we've gotten 4 marks from that. All right, so very good, Makeda. See where you got that. Good. All right. Now, so of course, we'll have justification guide tells us that you must think. You must think. What do we mean by think in this context? Identify the key words. Like earlier, we talked about product. That was a key word. Good. Query. So the first step in the justification guide is to identify the key word. Good. And the word query, now the second step in the justification guide, that says ask yourself, what does the keywords mean? Just like what we did earlier. What does product mean? And of course, Makeda in YouTube says to multiply. Then the third step in the justification guide says we're to consider, does what you have match your keywords? And then of course, the last step is act. What do we mean by act in this case? It means that you use the keywords and what you have to make an argument. Good? Which is hence the solution. Let's now move to part 2 of part B. It says using the matrix method. Let's kind of bring it up some more. Using the matrix method, solve the simultaneous equations. Now, so you're asked to use the matrix method. Whatever you're asked to do, that is what you must do. If you don't do what you're asked to do, I can bet you your last dollar that you are going to lose marks. You must do what you're asked to do, otherwise you will lose marks. Okay. However, though, to be on the safe side, I was teaching some of my third formers and fourth formers a little technique in solving simultaneous equations. And of course, this technique is really based on trial and error. Have you ever heard about trial and error before? Yes, I know you have. So this one is based on trial and error. Trial and error. I'm saying, sir, trial and error, what do you mean by that? Let's use the trial and error method first. To find the value of x and y. And you use it as your landmark. So it means then, if what you're doing might be wrong, at least the trial and error would have given you correct answers before you proceed to using the matrix method. Now, how does this trial and error method works? Now, we're talking about solving simultaneous equation. Really what you're asking yourself is here. What is the value of x when multiplied by 2 plus what is the value of y when multiplied by 3 to give us 5? To give us 5. Now, you might be tempted to say x is 1, y is 1. Because yes, if you did that, of course, 2 times 1 is 2 plus 3 times 1 is 2, which just gives us the value 5. But in simultaneous equation, the second equation must have the same values of x and y as in the first equation. So if you try the same 1 and 1, negative 5 times 1 give us about negative 5. Plus 1 certainly is not 13. So therefore, x is not 1 and y is certainly not 1. So let's try again. What then? What then is the value of x and the value of y that satisfies both equations? Think about it. I see Makeda says she used the trial and error method a lot. Okay, all right. All right. So I want to try to use the trial and error method to come up with the values of x and y which satisfies both equations. Try that one. Hmm, hmm, hmm. This is a big question. Nobody find the answers yet? Trying it out, Lexi?
Yes, sir.
Okay. I found the answer already, my trial and error method. Just waiting on you to find it. I found the answer. So, Makeda, since you said that you have used this method a lot, let's see what you came up with. So I'm waiting on Lexi and I'm waiting on Makeda and other persons who are on our YouTube channel to come up with the values of X and Y that will satisfy both equations. And I found my solution set, which will do so. And it will practice. So when you get down to the algebra type questions and you ask to solve some of this equation, you can use the same method to arrive at your values of X and Y quick and fast so that you don't have to waste time trying to figure out if you're right or wrong. So let's see what you come up with if you have what I have. Okay, Marquez is doing it now. All right. Okay, let's do it now. Let's see what Lexi has. All right, no Lexi. 3y negative 2y. Well, you have the values, but why do you put y? Don't you put the word letter y in it? Just tell me what x is and tell me what y is. Tell me what x is, tell me what y is. So you have the values correct, but the statement is looking awkward. Is the trial and error method used, Lexi? Or you just work it out?
Sir, I don't know how to use that somewhere.
You know, it's what trial and error is, there's no way. You're just trying to figure out a value of x and a value of y that is satisfied. That's how they're doing. There's no special way. If you know how interesting that method is, you do it. Trust me, you try it. There's no special way to it, man. No special way. No special way to it.
Sir,
Yeah, go ahead.
can somebody that is not a part of the institution be a part of the meeting?
Yeah, I guess. I mean, Wednesday's exam, it doesn't really matter.
Hmm?
Yeah, man, they can, yeah.
Okay.
All right, so Makeda, you got it, Makeda? Got the answer, Makeda? Makeda, have the answers yet? All right, just giving you guys about maybe 2 minutes more to figure it out. Then I'll tell you what the solution set is, and then we'll move into using the matrix method. All right. Okay. So let's get to the answer. Now the solution set for that is as follows. Still trying, okay. It is actually this. All right, so while Makeda is still trying, I'm gonna go straight to the answer. Hope she get it before. So it is x is negative 2 and y is positive 3. That is a solution set. X is negative 2 and y is positive 3. So let me just type the team properly again. So our solution set for the answer is where x is negative 2 and y is positive 3. So I use the trial and error method to arrive at that answer. So now I'm going to be using the matrix method now to arrive at the answer. All right. For those who are just joining us on YouTube channel, you might be wondering how you came up with that negative 2 and negative 3. Well, I just simply asked myself the question, what values of x and values of y that when multiplied by the coefficients at the top will give me 5 and 13. So they have to both satisfy the equation. So I recognize that, wow, what two numbers will give me 13? 10 plus 3. Good. So I said, all right, 2 times 5 will give me negative 10, right? But hold on a minute there. Let me double check on that first. Yeah, negative 2, I should say. Negative 2 times negative 5 will, oh, you had both positive and erase. Okay, you had both positive, but both positive would work, Makeda. Yes, so Makeda is helping us in the explanation here. So you have to try different numbers until you get them, till you find the right pair of numbers. That's really what trial and error is about. Trying different numbers until you find the right pair of numbers. Thank you very much for that, for the clarification in the explanation, Makeda. Thank you very much for that. All right, so we want to go further now, furthermore into the lesson. All right, so the read of the fact, when we talk about the trial and error method, we're talking about trying different numbers until you find the right pair. And remember now, when we talk about trying different numbers, you will have negative and positive integers working along with. Good? So negative 2 times negative 5 would have given us a 10. And if naturally y is 3. So you try that back in the first equation, negative 2 times positive 2 will give us negative 4. And then 3 times 3 is 9. So negative 4 plus 9 will give us positive 5. See? Simple. So we have our solution set. Let's go to the matrix method now. Now, the matrix method, you're going to remove the coefficients and have them by themselves. So you have 2, -5, 3, and 1. Where did that 1 come from? Because, of course, you know, there's a 1 right here beside the letter. Good. Then you put letters by itself, x and y, equal to 5 and 13. All right. So remember now, we're targeting -2 and 3. So the trial and error method basically allows you to have your answers already. See, all the headache gone already. So all you have to do is ensure now that you have learned the matrix method and you know to apply it. So using both methods, I think, is wise. So practice to develop your trial and error skills so that you can master it before Wednesday. All right, so let's go. Now, so the first thing in the matrix method is to make the coefficients by themselves as a matrix. Then you write the x and y as a matrix and the answers as a matrix. So if you observe, you'll see exactly what to do for the first step. Now, what is the second step? Now, the second step is to find the inverse of the matrix. Inverse of this matrix right here that I'm circling with my pencil. Good. How do we find the inverse of a matrix? Now, to find the inverse of a matrix, you need 2 things. Let's see what are the 2 things. To find the inverse of a matrix, you need 2 things. 1, determinant, and secondly, you need to find the adjoint. And the product, so the inverse then is the product of the determinant and the adjoint. So the question is now, how do we find the determinant of the matrix? All right. Let's see how we will find that now. So to find the determinant of the matrix, you have to multiply. Look at me carefully now. Look at me carefully now. You multiply, let me change the color. You multiply the leading diagonal elements, which is this right here. Then you're going to subtract the product of the non-leading diagonal. Let's change that color so you can see clearly what's going on here. So this one is a non-leading diagonal. Good. So you find the product first of the leading diagonal element, then subtract from that the product of the non-leading diagonal elements. So the leading diagonal is in blue, the non-leading diagonal is circled in black. So let's now do our find the determinant. So let's just come to the top right here. And of course, you put the determinant between 2 lines like that. Good. So let's call it matrix A. And therefore, that is equal to product. So that's 2 times 1 minus -5 times +3. See? Oh, so apply sent out for the matrices from a long time ago. That's equal now to +2. So -15 is obviously going to become +15. You can put in a calculator and get your answer. So the determinant clearly is equal to 17. That's the determinant. So make note of the determinant. Make note of the determinant. And I pause here a bit and ask you if you know anyone that wish to participate, wants to join the class. Oh, excuse my bad manners. That's Lloyd. Good night, Lloyd. Hi, man.
Good night, sir.
Okay, good night, sir. How you doing? Welcome to CDPLABS Services. I hope that after tonight you will be able to learn as much as you can, and by God's grace, you'll be blessed, and of course, do well in your exams from Wednesday. All right. So we are looking at 2019 paper, starting at the back and moving up. So we're going from this descending order. Right? Good. All right. So we just found the determinant of the matrix. Now we're going to find the adjoint. So we have the determinant, which is this. Let's go to the adjoint now. The adjoint is very simple. The adjoint is very simple. So let me rewrite it. The adjoint is very simple. To find the adjoint of the matrix, so remember now that this is the matrix right here. Let's rewrite it here. 2, 3, -5, and 1. So I'm going to change the positions of the elements in the leading diagonal elements. So again, what is in blue are circled by blue. That is called the leading diagonal element. So we're going to be changing the positions. Let's come over here. So where 2 is, where 1 is, I'm going to put, where 2 is, I'm going to put 1. And where 1 is, I'm going to put 2. So I've changed their positions. So now I'm finding the adjoint. Good. Now all I need to do is to multiply the other elements now by -1. So -1 times -5 is +5. And -1 times +3 is -3. So now we have our adjoint rather. So we now have our determinant and we have our adjoint. Now what do we do with them now to completely find the inverse? Simple. You just put 1 over the determinant. So the inverse then is a product of the reciprocal of the determinant times the adjoint or the adjoint of the matrix. That's the inverse. Now you might, it's just read a fraction then. So 1 over 17 times 1 will give us 1 over 17. 1 over 17 times -3 will give us -3 over 17. 1 over 17 times 5 will give us 5 over 17. 1 over 17 times 2 will give us 2 over 17. Now, I deliberately did not write that on the board because that's not necessary. You could just simply leave it at this and you have gotten your inverse. Now, watch me carefully now. So I'm going to move this now, 5 over 13, and put it in the party. Let's join the party right here. Yes. Simple. Good. Now, so guess what now? We have 3 factors right here. We have the reciprocal of the determinant, we have the adjoint, and we have the answers right here. Now, for me, the easiest thing to do is to multiply the adjoint by this. So row by column. So row by column means 1, let me get rid of something so it doesn't crowd the board. I'm going to get rid of this. You can always go back to the channel. Lloyd, I hope you have subscribed. Have you subscribed to the channel, Mr. Lloyd? Have you subscribed to the channel yet?
Not yet, sir.
I hope that after tonight you subscribe to our channel as well. Okay, sir? All right, let's go. Now, that is your admission fee, just to subscribe to the channel. All right, good. All right, let's continue from that. So we're going to multiply row by column now. So 1 times 5 plus negative 3 times 13. And of course, this is going to become negative 39. So we'll remove the plus sign, of course. We're going to have a negative number. So minus 39. Let's put the results. So let's put this as 5 minus 39. Good. And how we got that 5? So we multiply 1 times 5, take the 3 times 13, give us that. And the result right there will be negative 34. Right. Then now, the other row by this column. So 5 times 5 is 25. Plus 2 times 13, which is 26. And then when you add those two, how much do you get? How much do you get when you add those two? Anyone? Anyone?
51.
Huh? How much? 51.
Mhm.
Okay, good. All right. So now we can come back to this side. We have 1 over 17 times negative 34 over 51. So it looks simpler now. Simpler when you multiply the adjoint by this. Much simpler. So 1/17 times negative 34. What's that equal to? Multiplication of fractions now. So you simply say 17 into negative 34 is how much? How much time can 17 go into negative 34?
How much time what?
Can 17 go into negative 34?
Negative 2 times.
Negative 2 times. Exactly. How much time can 17 go into 51?
How much time 17 can go into what? 51?
Yeah, how much time 17 can go into 51? Yeah.
3 times.
3.
3 times. 3 times. So, trial and error gave us the correct answer. Use the matrix method, got the same answer. So you see, using the trial and error method first gives you your answer right away. But, well, not a but. So you know, don't need to get anxious because you know what you're working towards. You're working towards negative 2 and 3, and we got it. So the trial and error method would have saved time, give you at least a score of
Time
1.
would save time.
What is it, Lexi?
How does it save time?
All right, it saved time because 1, you'd have already got the answer already. Let's say you did not start the exam. Hey, go ahead, Lexi.
Continue, sir.
Yeah. Let's say that you did not start the exam at the back. But by the time around, you can use the trial and error method and bam, bam, bam. You get your mark. You get that 1 mark. And sometimes the examiner.
Sit down and think, well, which number for to get that time though.
Yeah, but guess what? Which one is easier? Trying to remember how to find what's the matrix method, or trying to just juggle with some numbers? Which one is easier?
The trial method.
Oh, that's my point.
Just take up
That's-
time.
it appears to take up time now, but with practice. Because I found it very fast because I was practicing to use the method. I just discovered the method last week, and I said, wow, let's try it. And I tried it with my students. So I get
Oh, you
faster
said
and
it
more.
now? You look what two numbers can go together?
Yes, yes. You try different numbers for x and y, and they must satisfy both equations. That's it. They try two different pairs of numbers, x and y, that will satisfy both equations.
So
But
how you
remember
come up
now,
with them number then?
yeah, go ahead, Lexi.
So how you come up with them number then?
Trial and error. Trial and error. That's what it means. In other words, trial means get what? You test something, you make a mistake. Try something else, make a mistake. Try something else, make a mistake until you get it. But all right, the faster way to do it is like this then. You say what two numbers when add together will give me 13 in this case. 10 and 3. But negative, but negative what? What 10 and 3. So how do I get um the first number to be 10? Well, obviously multiply by positive 2. So now x is positive 2. And then y must be 3. Simple. So you ask yourself the question, what two numbers when add together will give me 13? Now, it didn't have to be negative 2 and 3. Could have been, I mean, 10 plus 3 is not the only two numbers. You could probably add, like, say, 9 plus 4, give it 13. But what number multiplied by 95 give it 9? That wouldn't work. So you understand? That's what it's called, trial and error. But yeah, it comes with practice. You have to practice it. And so it works out for you. We're going to say we can try some trial and error throughout this exercise tonight, and let's see how it works. So maybe tonight you can get some more practice and see how it works, right? But just to go back through the question with the overview, for those who just came on, we're welcome to CDPLABS and services. Those on our YouTube channel. We're seeing 6-7 persons watching us now. And all those persons who are watching, if you like what is going on here, we ask that you like it, you share the link with someone else, and make this, we're sharing with the wider public tonight, so ensure that you share and keep sharing. Now, so what we started off with was a trial and error method to give us our actual answers. Then the matrix method requires you to multiply the inverse, to find the inverse of a matrix. So you first have to learn to set it out. So step number 1, you remove the coefficients, that is the 2, the 3, the -5, and the 1. Write it in the matrix by itself. X and y equal 5 over 30. Simple. Step number 1 is the first step. Then now your second step is to find the inverse of the matrix, which is a 2, 3, -5, 1. Or the matrix, the inverse of the matrix formed by the coefficients in the simultaneous equation. To find the matrix, you have the inverse rather, you must have the determinant and the adjoint. How to find the determinant? You multiply the leading diagonal elements, then find the difference between the product, find the difference between the product of the leading diagonal elements and the non-leading diagonal elements. Simply we have said it. Once you find that, you put the 1 over the 17. You need to find the adjoint, which simply changes the positions of the leading diagonal elements and multiply the other elements by -1. You did that right here. Then you put together 5 over 13. You find the product of this matrix and this matrix, which is row by column, end up getting -34 over 51. They use the 1 over 17 as a scalar, and you multiply. So it's just simple as, the 17 into the 34 give us -2, 17 into the 51 give us +3. And that's it. All right. If that was not clear to you, all you need to do is go back to the channel so you can hear it. All right, I was trying to see if I can run through a lot of questions before we all get sleepy. All right. All right, so that is that for matrix. All right. Now, let's look at part B question now. Relative to the origin, let's see if I could reduce this a bit. Right. Now, if I like to tell my students that before you read the worded part of a question, just look at the diagram, see what you know. See what you know. Now, of course, if you notice that B is written in coordinates 3, -6, A is 9, -0, and 0, O is 0, -0. Now, if you're in the exam, because they cannot carry paper in the exam, well, they may have graph leaves in the exam. You ask them for a graph leaf, even though it doesn't require you to use a graph. But you can plot back these same points on the graph paper and draw the same triangle on the graph paper, and then you're good to go. But when you're plotting the points, ensure you're not drawing out the triangle by itself on the graph. You're drawing the T graph, or you could just draw the L graph like this. Draw your L graph like this. And you roll it up like we normally do a regular graph. Plot each point, and then you connect them so you can get what the same triangular figure. All right? Is that clear? Is that clear?
Yes, sir.
Yes, sir.
Right, thank you. Now, so let's move on the rest of the question. So, all right. All right. Now, they ask us. So now let's get back to the guide. It says, let me get back to the guide itself, but let me get to the question first. So it told us, relative to the origin, O, the position vectors of the points A and B are OA, 9, 0, and OB, 3, 6, respectively. The points D and E are on AB and OA, respectively, are such that AD is 1/3 AB. Now you don't know what AB is. So evidently they're going to ask, you should ask what AB is. And OE is 1/3 OA. Okay? Now, this is what we refer to as, I think it's collinear. All right, collinear. Good. So they are collinear, means that they are on the same, the OE is on the same vector as OA. So it's collinear. All right. See, I told you, we're going to find AB. So because it developed that kind of mind, you'll be able to guess and know exactly what they're going to ask you before we get there. Right? So they're going to ask you for AB. They're also going to ask you for OD. See? All right. Let's go. Now, to find AB, the first question you should ask yourself, let's see what you have learned from previous classes. What type of vector is AB? Anybody knows? What type of vector is AB? Anybody knows? Yeah, position vector. Another type of vector starts with a D. Begins with a D. What type of vector is AB? What type of vector is AB? What type of vector is AB? Anybody knows? Good night, YK. I don't know who's YK. Who's YK? All right, so Javon, welcome back, Javon. Bart, you're correct. It's a displacement vector. So welcome back, Javon. All right, could the person identify themselves? Let me hear your voice. YK. Go ahead, Lexi.
I was asking what type of vector?
Yeah, it's a displacement vector. Javon told the displacement vector is correct. Right? So who's Y key? I don't know Y key. Lexi knows Y key.
So
Could Y key give me that name? Change your name to name so I can get your name. I don't know what your name is. Y key. I don't know who's Y key. All right. Well, let's continue. All right. Now, so to arrive at the displacement. Oh, so this Tavian Davis. Yes, one of you would know that person. Welcome to CDP
both of
Labs.
us know.
Go ahead, Lexi.
Both of us know.
Both of us don't know.
Both of us know.
Both of us know. You mean you and I know?
You say if anyone I will know the person. So I'm saying both of us know the person.
Okay. All right. So welcome. That's Steven Davis. Welcome. Good night. Okay. Good night. All right. Oh, so okay. No, it's not a parallel vector. It is more displacement vector, Makeda. All right. So let's go to it now. Now, when you're going to express your answer for a displacement vector, you will have to use two position vectors. Now, match the two letters here, A, which is the starting point, B, which is ending point, tells us exactly what two position vectors we'll be using. Now, the question clearly states that they are position vectors. So OA is one of the position vector, and of course, OB is the other position vector. And in vectors, you add them. So let's see how we add these vectors. So let's see how it is done. So we'll be adding OA plus OB, but that must be written as OA plus OB. Now, how do we get AO to come to, how do we get OA rather to become AO? Simple. Let's look at what OA is first. OA is 9-0. Now, AO will be the opposite, which is negative. Let's look at that. So OA is written as 9-0, but AO is written as -9-0. Now you do have a -0, so but if there's another number instead of 0, it becomes negative as well. All right, so I've never heard about -0. Okay. All right, why I turned it. All right, very good question. Now, it's a matter of direction. If from O to A is here, but you want to get you want A now to be the starting point. OA has O as a starting point, but you want A now to become the starting point. So naturally, A to O. Is that answer satisfactory, Ms. Ford?
Yes, sir.
Okay. It's the first time I'm answering the question like that. Okay, thank you for asking. All right. So it is -9-0. So we have that. So we write it as now -9-0 plus what OB is. What did they say OB is again? OB is 3.
36.
Thank you. 3-6. So let's finish writing that. There's 3, 6. So we have to add the vectors. So -9 plus 3 will give us -6. 0 plus 6 will give us 6. Therefore, AB, the vector AB is -6 6. And let's go over that again. So it is clear to you. All right, let's go over it again. So it's clear to you. So first thing, we must identify the two positions, identify what the type of vector is. It is AB, which is a displacement vector. What do we need to arrive at a displacement vector? We need two position vectors. How do we know which position vectors to use? Naturally, use the letters in the displacement vector. So it must be OA and OB, two position vectors. So OA and OB. But we need A to be the starting point. So we have to come from OA to AO by multiplying the elements in the vector by -1. Therefore, we have -9, 0, plus OB, then we have our answer. All right? Is that clear to everyone?
Yes, sir.
Yes, sir.
All right, thank you very much. All right, let's clear that. All right, let's move to the next part of the question now. So we want vector OD. No, hey, very good question, eh? No, let's see here. No, vector OD is a position vector. So therefore, we need the coordinates to find the position vector OD. What do we know? What do we know? What do we know? No, we know that D, the point D, is a part of the point AB. So we know that AD is equal to 1/3 AB. Now, this is where you're required to do some thinking, some reasoning. Reasoning. You gotta be smart with it now. You gotta be observant. We talk about how would you approach a question. You have to observant, right? Now, being observant is very, very important. How do we be observant here? We see that more persons are popping into CDPLABS of Service Maths Marathon. Now when Matthew gets on, I say, welcome on board, Matthew. Good night. Good night, sir.
Sir, I don't know.
You don't know Matthew?
No, yes, sir, no.
Oh, okay.
I said I don't know if I'm completely right, but since we already have AB,
Mm.
right? That would define right, sir.
Yeah,
Would
go ahead.
we-
Go ahead, next time. Start over again. What were you saying? Go ahead.
I'm saying I don't know if I'm correct, but I'm gonna try. Since we have already found vector AB, would it be that we multiply that 1/3 by it?
You mean vector AB?
Yes, sir.
Yes, you'll have to do that. That's true.
So that is not the complete answer?
No, you're not finished yet. You're not finished yet. Because you found AD, we want to find OD. But you'd have gotten AD, so you'd have multiplied the 1/3 by the AB. That's good. Good reason right there. Yes. Trial and error, isn't it? Good a bit of reason, eh? Good. Yes, so you took a risk, a calculated risk. That's good. Yes, that's correct though. So you observe, so that AB is, we already found it already. Therefore, 1/3 of what we found must be equal to AD. So good reasoning. All right. Very good question and good reason. Great attempt. So let's look at it. So let's try that one. So AD, so we know that AD is equal to 1/3 AB. Good reasoning, right? So we know what AB is. So that therefore that AD is equal to 1/3 -6, 6. And therefore equal to what?
-2, 2.
-2, 2. Thank you. Right. So we know what AD is. So question now. Let's see if you're thinking. So if AD is -2, 2, based on what you already know, what question should you ask yourself first going forward now to find OD after doing all of that? What question would you ask yourself? Because you see, in understanding the exam questions, as we go from step to step, you must ask yourself questions. Asking yourself questions is a way of igniting your brain to think. So, go ahead. What question would you then now ask yourself? Because that's what Lexi did earlier. She asked me, but technically, she asking herself, right? So, what question then should you ask yourself now? Now knowing that AD is -2, 2. And in light of the fact that we need to find OD, what question then would you ask yourselves? Waiting for the answer. No question? Come on, guys. No question? Anybody on YouTube? What question would you ask yourself? Okay, I see chat comes in. What plus A give you AD? Then what do you think? All right, what plus A give you AD? I see that Lexi. Okay, you kind of want to fix that question up. Javon says OD will be equal to OB plus AD. Oh, I like Javon's one. OB plus AD will give us OD. Okay. I wouldn't use OB in this case, though, Javon. I wouldn't use OB, but nice try, Javon. Nice try. Nice try. But you can fix it up, Lexi. What do you think it is, Lexi? What plus A? Give you AD. Nice try, but try again. Javon, try again. Well, Makeda tells us that OD is 7.2. I don't know how Makeda get OD to be 7.2, but we're not asking for the answer as yet, Makeda. We're really asking for the question you'd ask yourself that would lead you into the correct answer. I think I give you enough chance to think, so let me hurry up to the question. But remember though, you have to practice to ask yourself questions pertaining to the question itself, all right? So here we go. Now, AD is a displacement vector. Oh, Javon, it's like seriously? Try again, Javon. Now, please note that AD is a displacement vector. So to get a displacement vector, you need two position vectors. And I did tell you before that the letters in displacement vector would have given you a hint to what the position vectors would be. Right, but naturally, AD would be equal to, come on, folks. AD would be a result of adding AO plus OD plus OD. It's supposed to be D, right? These would be the two position vectors. Now we know what AD is, and we know what AO is. Yes, that's what we're asked to find, OD. But we know what AD is, and we know what AO is. So guess what? If we have OA,
you're gonna minus it.
Plus AD, wouldn't we get OD?
Would we say?
Come again?
Would we?
Well, you don't really minus in vectors, so I wouldn't say yes. But the fact is that you know what AO is. We're going to spin that AO to OA. That's it. You see? So we know what is OA? What is A? Eh? What is OA?
90.
90. And then plus negative 2, 2. The answer then is 7, 2. And Makeda was correct. Yeah, Makeda was correct, but I didn't ask her for the answer. I asked her to tell me the question she would ask herself. Yes, Makeda, congratulations. The answer is 7, 2. Nice try, Javon. Nice try. But you have to think, students. You have to question yourself to get the right answer. Right? So, you see, when you question yourself, look how simple it is. You're using what you know to find out what you don't know. So first you have to establish what you know. You know that AD is a displacement vector. You also know that it needs two displacement vectors to form AD. What are these two displacement vectors? OA and OD. Good? OA and OD. But would have turned OA to AO plus OD to get AD. So then, we know AD and we know AO. When you add the two together, AD. See, but you have to think. Thinking is very important here. All right, and that mark, if we're to get that question correct, you'd have gotten marks to reasoning, to the reasoning component of the exam. Because remember what they mark it from: reasoning, computation, and understanding. So got to put yourself, think some more, push yourself to think so that you can get the score for reasoning. So don't go back to our grade 4. Now those who got grade 5 the last time, don't get grade 5. All right, so we have the next part of the question that we finished with the vectors and indices. Let's look at BE now. BE. What type of vector is BE?
So scroll up back and see the diagram.
Come again?
And I see the diagram again.
We want to see the diagram. Okay. We define BE.
BE.
Mm-hmm. We define BE. How are we going to find BE now? What type of vector is BE? What type of vector is BE? Mhm. What type of vector is BE? They want us to find BE. So what type of vector is BE? Come on, you have to answer that question. Right, so Makeda says displacement vector. That's correct. No. So,
What's the placement vector? Isn't it like, say it's short than
all right, put it this way. Let's see. If you want to have an O in a thing, I have 2 letters except for O, it's a displacement vector. Got that?
Mm-hmm.
You got that?
Yes, sir.
All right, just remember that. So BE is a displacement vector. It's really you're moving from one position vector to another position vector, right? All right. Now, so what are the 2 position vectors now that you need to find vector BE? What are the 2 position vectors that you need to find vector BE? That's the question here. What are the 2 position vectors? Yes,
OB
go ahead.
and OD.
OB and?
OE.
Very good. Let's go back to our information to see if we have them. All right, my kid, I don't like to first find OE, then find BE. I don't understand that. I don't understand that. I hope your friends next to will support us by subscribing to our channel. So Tavian subscribe to the channel, Marty subscribe to the channel, and then we are seeing Francis. Francis will also subscribe to the channel too. All right. All right. Just please encourage them to subscribe to the channel afterwards. All right. Okay. So Javon says B is equal to 1/3 OA. That's true. Right? 1/3 OA. So we need to find OB. OB is given, which is 3, 6. And then to find OA, Maxine Adams, good night. So Maxine Adams said, good night, sir. I find this site so late because I need so much more to pass this exam, but you are a miracle, thanks, sir. Well, thank you, Maxine, for that comment, but to God be the glory. Let's give God thanks for that. And just pray that I'll have the energy to stay up tonight to carry you through this marathon tonight. Because I am not the one that run through the questions. I need to give my students a chance to think through the questions as well, because that is what you need to do in the exam to safely pass this exam. Once your SBAs are intact and you have gotten through the SBAs already. So thank you for that comment, Maxine. You find the site so late. Really? Okay. Well, you're still here. All right. Now, so to find OE, we have to find 1/3 OA. Now we know what OA is, 90. So if you find 1/3 of 90, then what is OE? What is OE? That's easy.
So,
30.
30. Okay, very good. So OE is 30. All right. So we know what that is. Let's go now. Let's write them in now. So of course, we know that OB plus OE, then we turn it down, BO plus OE will give us BE.
6.
Good. You can see both numbers become negative. Right? Plus, which is what? Is 0. Therefore, our answer is -3 plus 3. 6 plus 0 gives negative.
And my internet are sorry, break up.
That me say for me alone, not you.
The place I like. I'm so much reconnect.
Okay. Back. Back. I'm trying to see if we can connect back to the YouTube channel. Not sure. I saw your question. We're starting from the last question, so we have not gone very far. So we're starting from the last question. I'm trying to get back to to the YouTube channel. Not sure we're back on it yet. Let's see. Can you all hear me now? Can you all hear me?
Yes, sir.
Can you all hear me?
Yes, sir.
Yes, sir.
It's trying to get back to our channel. Okay, thank you. Internet went down, just trying to get back to the channel. Uh, let's see if we could get back to the channel. Let's give me a second. All right, so let's try to get back to the channel. It's trying to load. Let's see if we can get back to the channel now. Not sure where you can see me. Makeda, if you can hear me, let me know. Trying to reload to get back to the channel now. Let's see if we can get back to the channel first of all. Still streaming, but I'm not sure if we're back in the channel. Still streaming. All right. Still streaming. Let's see if we can get back to the channel. All right. So we should be getting back. Let's see if we can get back to the channel. Let's see. Back to the channel. Back live again. Let's see again. Let's see if we're live again. Not sure if we're still live. Just waiting for the chats. Decide to go back and back live. All right. In the meantime, while we're waiting for the channel to view, I think we're back. No, I think we're back. I think we are back. All right. Not sure about that, but let's get into the channel. I apologize. It's the internet, it's technology some of the time. Let's get to, anybody see my screen? Can you all
Yes,
see my
sir.
screen? All right. So, all right, so we're back, and let's hope that YouTube will join us back shortly and get back to it. All right, so we're back to the channel now. All right, so let's see what's going on here. And still going on my side. And all right, so we discovered that we need to find, so we were at the fact that OB plus OE is what we need to use. And then we turn OB to BO plus OE. And then now BO is negative 3, negative 6 plus OE, which was what again? That was OE? 3, 0, right? Good. So our
Yes.
answer then would be 0, negative 6. That's the answer. Right? Right. All right. Still loading. Still loading. Right. So let's that. Clear to everyone. X is off. The other persons are other persons are online. Are you hearing me clearly? Tavian.
They're slightly breaking up.
Sir, yeah, break up.
internet is giving us a bit of problem here. Why? All right, but we're still back on again. Wi-Fi is full, apparently having some problems. Not sure, but thank you for standing by again. I hope that our YouTube persons are still standing by as well. We try to get them back in program. So let's see if they back up. All right, so let's get back to our question. And I hope that they will also rejoin us shortly. All right, so we're gonna go back to, so we finished with this question, so our first question for the night. So we're gonna go all the way now to our next question. And let's take it from here. Okay, so we're gonna go into a circle theorem question to resume this session now. All right, we're not seeing back our folks as yet, but let's hope that they will resume in the chat with us. Not sure that they are on chat as yet. I'm not seeing them in the chat, but let me see if I can find them from here in the chat. So give me a few so we can reconnect with them. Trying to reconnect with them and see if we can get them. Mix. All right, so we are now looking at a circle theorem. Now, what I normally tell my students to do is to redraw the image to scale using the information given. But first, let us identify a few things about this circle and the different figures in the circle. Let's see if we can do that first. All right? Let's see if we can do that first. All right. Now, not in the words in the chat, but not in the chat. Let's see if we can find the words in the chat. Let's see. Not see them in the chat. Let's see if we can find the chat. Okay, so we're live again in the chat. Thank you very much. All right, sorry about that, my folks. Thank you for standing by. We're having some technical issues on our side. Thank you for standing by. So we're back in action again. Just as I said, just pray that we'll be able to stay up through this night. We're now at the 11 o'clock hour. We are now 2 hours in our session. And of course, we are at our second question out of 10 questions, right? Okay, so we have 8 more to go. All right, so we're teaching and we're learning, not running through questions like that. All right, giving a chance to think it through. But let's look at what we know already. Can somebody identify, can any of you identify some things in this picture?
If we can identify what?
So you identify, so tell me what you can identify in this picture. Tell me what you can identify. And thank
Sir,
you.
Z angles.
Yeah, go ahead, Tavian. Go ahead, Tavian. Go ahead. Listen, go ahead.
Sir, I see Z angles are alternate.
You are seeing Z angles or alternative angles. Okay. All right. Okay, fair enough. Before anyone has responded, I just want to say thanks to Makeda for that prayer. Let's keep praying so we can stay live and direct as we continue with this presentation tonight. So Tavian just said that she see the Z angles are the alternative angles. Okay. Is there anything else that anyone else see apart from that? Is there anything else that we can see? Anything else? As you can see,
Dimension different type of triangle and one trapezoid.
Yeah, go ahead, Lexi, say it
Or
again.
that
Yeah, go ahead, Lexi. Repeat it
can
for me.
see different types of triangles.
Okay, could you name one of the types that is predominant there? Right, so Javon, you see the diameter, which is clear. Okay, that's very important. But tell me what else you see.
This is what, sir?
No, we see the diameter, which is AC right there. So tell me what you say you see different types of triangles. Could you name one of the triangles for me? And Makeda, she circles, lines, angles, and degrees. Okay, then all right, Makeda. All right, anybody else? The same one the type one.
Correctly.
Yeah, go ahead. What type of triangle is it there? Go ahead.
That correct?
I didn't hear it. Go ahead.
Hmm. So scaling.
So you see scaling triangles. Okay. All right. Yes, scaling triangles there. What other type of triangle can you identify?
Isosceles.
Isosceles. See isosceles triangle there? All right. So in my case, you see a dot. They stated the obvious. Okay then. All right. Okay, let's using our eyes. The dot is the center of the circle there, Makina. Its diameter runs through the center of the circle. All right. So you don't see there's a scaling triangle there as well, and there seems to be an isosceles triangle as well. What would that be? What would that isosceles triangle be though? Lexi, could you name that isosceles triangle for us? Could you name it? It appears to be an isosceles triangle. It seems like that. But just in name it, yeah, go ahead.
What I say?
Well, if you see two, you could name one. Name one of them. Let me see.
Sir, but more with it.
All right. Okay.
That one from
ABD. ABD looks like an isosceles triangle. Javon says a cyclic quadrilateral and a right hand. Right. So the cyclic quadrilateral that he's mentioned here, it is a right angle triangle. That is ADC. See there? ADC. That's a right angle triangle. And there's another one too. ABC. Those are two right angle triangles there. See them now? Good. And when Javon says a cyclic quadrilateral, it means the cyclic quadrilateral is A, D, C, B. That's the cyclic one.
I couldn't remember right now.
Oh, all right. Okay. I could say a four-sided figure, right? Good. All right. So it's very important that you're able to see things, see them, use your eyes, exercise your eyes. And that comes with practice. So you must practice it the next couple of nights that you have. All right. All right. Now, normally I don't go through questions like this with students. I normally tell the secret to them. And the secret to them is to use a geometry set, redraw the entire thing using the information that is there. So naturally, if you have the diameter, which is easy to find, then you put your protractor at the point A, measure the angle 28 degrees. You'd have gotten this card and you draw it straight through to B. When you get B, you will measure your angle from B and measure the angle 46 degrees. You'd have gotten this card straight through to D. What is that? Everybody sees that?
Yes, sir.
Good.
Okay, sir.
So, all right, if you have a geometry set, I'm going to ask you to try it. So, if does anybody in Zoom now have their geometry set? You have a geometry set? Huh? All right, I want you to draw it. Go ahead and draw it. I want to prove something to you. So, go ahead and draw it, and you're going to turn on the camera and show me what you drew. So, everybody's, and those who are on YouTube can, I will not be able to see what you have, those on YouTube, but if you want me to see what you have in YouTube, you could WhatsApp your picture, and I don't send any phony things now. WhatsApp your picture to 788-4378. So that's 876-788-4348. So those persons in YouTube could WhatsApp their picture to us, and I'll be able to share it with the students in Zoom so that they can see what you drew. So everybody use a geometry set and see if we can redraw this diagram using your compass, protractor, pencil, and ruler. Try it. Go ahead. Makeda, by this time you should have a scientific calculator and your geometry set, Makeda. Are you for real? Try and get those by Monday. Need it. right? And this covers it. Let's still try that too.
So the triangle ABC and BBC, them similar.
What's that, Lexi?
When I triangle ABC and BBC similar.
Triangle ABC and DBC. No, not really. Uh-huh. Because BDC is that would be a scaling triangle. It's not similar. I note that it must calculate the value of the angle, show detail working register, and give reasons to support your answers. But I want to use a protractor this time, your compass, ruler, pencil. Figure this out before we get into calculating it. I want to see some things first. You have to have a method, a backup method you can use to get the accurate answer without being nervous and wasting time, just guessing whether you're right or wrong. All right? Hmm. Nothing as it. All right, while you try that, let me see if I can find mine. I think it's All right. All right. All right. So while you're doing that, um, I can show you a bit. I'll show you a bit of thing first.
So what exactly we're looking for? 'Cause
All right. Let me show you. I'm going to show you what to do first. Let me see if I can stop sharing the screen and go over to my part. All right. So let's go over this side quickly. All right. So here we are. I want to show you what. So Javon is all right. So Javon is saying that that DBC to the 44 on the semicircle is equal to 90 degrees. Right? All right. So we'll see that. So here's our compass. So we're going to draw a circle, this, right? Let's see if we can draw it. All right. So here's the center. Good. The center of our circle. What is that? You draw the circle.
Yes.
Good. Now, let's just say we can find the diameter here. It's right here. That's the diameter there, right? Draw the line to diameter to the center. What is that? See that now? Then now, you're going to draw a line, come down. So look at what it looks like, first of all. All right. So therefore, A will be right here. This is where A is. Right here. And then we have C right here. Good. C will be right here. All right. So we have our diameter here. Now, we're going to take the protractor. So let's remove this. Don't use anymore. This can be removed. Try and see if I can remove it. Stick to that glue. Yeah, okay, right there. So let's put our protractor here now. Line it up with that. I want to measure out 28 degrees. Everybody see that? Everybody read it off? This is my protractor.
yes, sir.
Mhm.
Yes, sir.
Okay, good. So, draw a line. So this is 25. It's 30. So 2. So about right here, we're going to go right. 30. Right here. Am I correct? Am I correct?
Yes,
Yes.
sir.
Right, good. All right, so do the Move the protractor to the way. Now, so now that right here is 28 degrees. What is our got our measure it out a while ago?
Yes, sir.
Then no, we know we are now going to measure out now. We'll connect B to C. That's easy. So we have our 90 degrees right here. What is that?
Yes, sir.
Okay, good. Very good. Everything come so far. All right. We can measure it over 46 degrees now. Can we? Of course we can. So let's turn this round. Right. Push it up to the center here. It's in line with it, 0, 0. We have to look for 90 degrees. So this is not entirely 90. It's 90. Everything's lined up. It's properly lined up. Good. Then we're going to measure at 46 degrees. So here's 40, 45, this was 46. Let's draw the line. All right. So watch this now. Now this line is going to draw from B to D. So we're drawing, this is 40, 45, and here is 46, correct? Is it accurate? Right there.
Yes, yes.
Come up some more. Right? All right. Good. So I have our 46 degrees between this and this. So if you connect now this line with this point here, you should get, and this line here with this line here, that we're 90 degrees right here. See? We try it back. That's what I was actually saying. Understand now, Lexi? Now, if you use your protractor, you know that right here is 90 degrees, everything right here is 90 degrees. Here it is 28 degrees. What can we learn from this? What can we learn from this? Right here is 46. Right here is 28. This is 28. There's 46 right here. But we know that the other part of the angle right here is going to be 90. So everything right here is 90. Now, this is also 90. Good. But you can use your protractor. Well, let's finish labeling them first. So right here is what? B.
Yes, sir.
Good. And here is
Okay.
D. Now, if you had done all of this now, and you did it accurately, you'll be able to measure all the angles using your protractor. And you'd have gotten the answers for every part of the question instantly because you have measured them with the protractor. So it boils down to just you being able to use the protractor to measure every other angle that you need to find. Let us measure, let's use a protractor here and measure the angle at C. Now, this is approximately 85. What is in that?
Huh?
What is, huh? You not see it, teacher? Look at it. This is called 85. Well, if you're counting from here, if you're counting from here, 0 all the way to 80, it's about 85 right here. Well, sorry, not 85. It's actually 101. Let me see. 0, 10, 20, 30, 70, 105. 105. The note I told you is 101. 5. Agree?
Sir.
Go ahead.
Sir, the 19 on the on the straight line though.
Yes, ma'am.
No.
Don't ignore the first dot. Use this dot right here. Because the draw the line short, that's why. That's what you're talking about, Tavian?
No, sir. Sir, put it up, put it up.
Oh, you mean this? Teacher? Teacher, sir?
Yes.
That's
Oh,
0,
sir, I just
10.
see it.
You just see it now.
Mm.
This would be 105. Mm-hmm.
6, sir.
You get 6?
Yes, sir.
All right, 106. Okay. All right. But, all right. So 106. Now, I'm going to show you how to calculate it afterwards, but I want to have an edge, meaning that they use a protractor, measure it, bam, 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 you have the answers then. Then now we can talk about calculation otherwise. All right. So I just want to show you a method they can use. Get all the answers that circle theorem don't become a headache anymore. Good. Now, let us go and examine this thing some more, right? Let's examine this thing some more. I see a response, Javon. So we're going to be investigating that some more, right? No. So let us look at it. The sum of the interior angles in a triangle is how much? What is the sum of the interior angles in a triangle?
180.
180. Good. Now, we can find the angle right here at C. At C. Because we know that everything right here is 90. So 28 plus 90 minus 180 is how much? What's that answer?
62.
52.
How much?
62.
62. All right. 62. So right here is 62. All right. No. We are not yet finished. We want to find the angle here now. Everything right here is 90. But if, all right, okay, let's see what's going on here. This is 90 here, and 90 here. That's 180, eh? And what are the what's the sum of the interior angles for a quadrilateral?
What?
How much?
Sorry.
260. Good. All right. Fair enough. Fair enough. Now, All right. All right. Now we define now. Okay. Right. All right. Now the angle, this part of the triangle, if we can figure this out, we have everything right here. Good. Now we can figure it out. We know that this part here is 90. Good. To find out this part now, we know it now. You said 106, true? Let's put 106 out here. We will find out what this part is, this portion is. Let us see. Now, what's the angle right here? What's the angle right here?
44.
Much? 44. Right?
Mm-hmm.
Okay. That's 90. Okay, good. And of course, you can use a protractor and measure this too. Right? What's the angle right here?
28.
Sure? 28. That's all right.
Sharon, is it uncle?
No man, right here. At C, right here.
Oh, the entire thing.
Yeah.
90.
No, 106, remember? So you want to find this part now. You have to take the 62 from the 106.
44.
From C to
This is
To
44 right here.
106.
Remember we're told that from here to here, or maybe the protractor got 106. This is 44. Two from give you 4. 6 from that give you 4. So right here is 44. Right here is 44. Right? Okay. So if here is 44, here is 90. How much is this up here, sir? If you're Georgia, can use a protractor.
46.
46. Okay.
Excellent.
46. Okay. We're assuming that out of these two, we use a protractor now and measure to see if it's correct. Out of those two, what the angle is.
74.
All right. Let's use our protractor now. Let's see. See? Approximately 74. Let's tell it. All right, 74. So that means this angle is right. This angle is right. This angle is right because we are protracting everything right here. Now, so we have all the angles now. Of all the angles. So let's go back to the question.
So we don't need to split the 90-degree angle, sir.
Not necessary. I mean, if you want to, you can. You can if you want to. Depends on what you're asked to find, right? But the point I'm trying to make is that you can use your protractor and find it. You don't have to kill yourself. Follow now? Make sense? Make sense? What not?
Yes.
No. That's what I wanted to understand. You can use a protractor and you can find it. So in other words, you might not remember the theorem. the time you spend time with the theorem, you get part of the answer right. That's the essence right here. All right, let's get back to the question now. We'll come back to our diagram. All right, so we'll look at the essence of the question. Now, so the question says, so we redrew it to scale, and now we know all the angles. We can find all the angles just using our protractor. Let's say calculate the value of each of the following angles. Show detailed working where necessary. Where necessary. So if it's not needed, you don't have to show it. Make sense?
So
Make
we're not
sense?
going box.
Huh?
How much marks it
How
worth?
do
We're
you-
not going.
How much marks it worth?
Mm-hmm.
2 marks. The calculation is 1. The reason is 1. So 2 marks. Now let's go to the calculation. I've identified DBA now. D B A. So they want to find this as long as it's 44 degrees. Now, why is it 44 degrees? Now, what type of angle? Now, please know that AB, what type of line is AB called? What type of line is AB called? Go ahead. Go ahead, I didn't hear that. Go ahead.
A straight line.
No. Have a name.
Corridor.
Go ahead, Tavian. Tavian, go ahead. I didn't hear that. Go ahead. Tavian.
Sir, never mind. Never mind.
No, man, I hear you say the right thing, but you're not talking loud enough. Just repeat what you said.
Sir, I said chart or card.
It's a card, yes. But why? You afraid to talk?
Oh,
Must be confident, man. You're correct. It's a card. What type of line is BC? What type of line is BC?
Circle.
A card. All right. So hear the argument now. Hear the argument now. Hear the argument. If you notice that the point A and the point C is the diameter, right? But if you also notice that the chord AB and the chord BC meets at a right angle on the circumference. On the circumference. However, both chords are in the same sector, or you would say semicircle. So the two chords are in the same semicircle. Exactly the same semicircle. They will no doubt meet at a right angle. That's the reason. You can test it for yourself.
say it again.
If you notice the chord AB and the chord BC meets on the circumference and they are in the same semicircle, they'll meet at a right angle. You see that? So you have to use your eyes and look. So you know the name of the lines, look to see where they are, where they meet. Where are they? They are in a semicircle. They're the same semicircle. And they both meet on the circumference at the semicircle. Will always form angle of 90 degrees together. Always. That's the reason. Already? So you can write the reason based on your observation. Make sense? So the reason can be written based on your what? Observation. So the calculation now, let's go to the calculation now. So we know it's already 44 because we measured to the protractor already. So because of that reason now, we can say 90 degrees minus 46 degrees. Let me give the reason. The reason must be stated using what you observe. Because it might not, don't try to memorize the theorem itself. That don't make no sense. Just describe it according to what you observe with your own two eyes, and technically you'll be describing the theorem. Because that's how they come up with the theorem. It's observation. Is that clear? Simple observation. All right. All right. Good. Any questions on that?
No, sir.
Any questions on that? Huh?
No,
No
sir.
question. All right. Let's move on. Move on. All right. So we found that 2 marks. We're to find now angle DAC. That's where it is. DAC. So we want to find this angle right here. This angle right here. Now, we use our protractor and we found that angle already, didn't we? How's that angle that we found? Using our protractor.
At angle?
It was 46 degrees. It was 46 degrees. But we measure, but we use the protractor and measure it. But the answer is 40. It's 46 degrees. Now we know that this is 90 right here. But we have to find out now. Oh, wait, this angle right here. It's 46. Let's observe. Now, where point A is, DAC. So DAC is 46 degrees. But what calculation can we make to find that? We know we have 90 degrees right here. What about the angle form right here? What's the angle form right here? What's the angle form right here?
I think it was 46. Is that 47?
Okay.
44? I don't remember.
44, yes. It was 44 right here. So then this angle being 44, How's angle form right here too? 44.
Or,
So we have alternate angles right here, right? This
mhm,
angle and this angle here, the alternate. What do you get that?
okay.
The Z, right? So look again. Make sure. Look at it properly. Right. So 62 right here. That's 44. Right. Right. So C is 44. Let me see now. It's 28 right here. So they kind of funny, you know. Hmm. All right. There are different ways you can look at it. This is 44 right here. So from the Z. They say we can trace it in this one. We have to make sure. From here, David, is that it, David?
Yes.
Is it funny, don't it? So that means this angle right here, that's all. That's what the Z's are. So this is the Z right there. That means that those two angles are with alternate angles. So that'll be 44 degrees, right? So that's that the alternate angles right there. So at 44 now plus the 90 here, and then subtract everything from 180 would have given up about this answer right here. So let's add that. So 44 plus 90 is how much?
It's 134.
Much?
134.
And subtract that from 180.
46.
46. Good. Forget it, Bob. All right, good. So you see as it's alternate angles. These angles are alternate. So that uses a reason that the angle B and C are alternate. The angles form that B, form that C are alternate to each other. Therefore, C is 44. Add that to the angle form at point D, which is 90 degrees. Subtract it from the sum of interior angles of a right angle triangle or a triangle, and you get this angle A, what they're asking for. All right. You have to be observant, as I said before. All right. Let's move on to the next one. All right. That's BC. BCE. BCE. So, from here, BCE. What angle would that be? Buddy?
BCE.
Mhm.
BC.
Which that BCE would have been the angle on the outside. Formed between right here. BCE. Again, you can use a protractor to measure that.
It's about 70. So
70. Yeah, I said that.
I mean, 110 somewhere there. So
Awesome. Remember now, you know.
try my job good.
Remember the angle form here. The year was 106, and so 106 according to who said it? Lloyd? Who said it?
Right.
Yes,
Mhm.
sir.
Yeah. So therefore, that's a subtract 106 from 180. Angles on a straight line, remember? Angles on a straight line. So much to turn out
Yeah,
to be.
74.
How much? How much you get?
74.
74. That different now.
See, we did close.
Wait a minute, wait a minute.
I said I was close.
Hmm?
I said I was close.
Oh, you're close. Okay. 74 again? You sure 74?
Sorry, I said if that equal 106, then since it's a straight line, we're going to minus 106 from 180. We're going to left 74 degrees.
Yeah, so I'm the 74 degrees. That's correct. 74. All right, good. And of course, if you use a protractor, you don't come up with the same 74 degrees as well. So the
Me
whole,
that is what a 70 we get.
come again?
So me use the protractor 70 we get, unless something not dry good.
Well, that means never draw good. That's what that means. Never draw good, and that's why you get that answer. All right. All right. But I hope what you should learn from this session, this question itself now, is that by using the protractor, the join set and rejoin a figure. Once you draw it properly, you get your accurate answers. All right. You observe the diagram and use what you observe to state your reason. All right. All right. That's regular theorem, difficult for you once you have those equipment. All right, let's go to part B of the question quickly so we can finish our two optional questions here and move on from this. All right. If you wanted us to take a break, you can let me know so we can take a break, listen to two songs, and get back into the session. If you want to break, let me know. Anybody wants to break? Anybody wants to break?
I'm okay. I don't know about anybody else.
Okay. I have to finish this question. I have to finish it. As the diagram below shows a quadrilateral PQRS where PQ, let's look at it. Before going to let's look at it. What shapes can you identify in this diagram? What shapes are these? Yeah, go ahead.
Try.
Yeah, go ahead, Lexi. Lexi, go ahead. I didn't hear you.
Try said triangles.
Triangles, okay. Another shape?
Trapezium.
Astavian, trapezium. That's good. Excellent. So see, a trapezium, also two triangles. All right, good. And of course, a quadrilateral, as indicated, which is a trapezium. All right. Now, the length, they tell us now that PQ and SR are parallel. So naturally, evidently, that will be a trapezium, right? Good. Now, SQ is 8 centimeters. And SPQ, all right, so my case must continue. All right. SPQ is 90 degrees. And the angle at SQR is 82 degrees. So note SQR 82 degrees. And the angle at QSR is 30 degrees. Middle letter, the angle. Middle letter, the angle. Now they want us to find the length PS. The length PS. I have a big fat question for you.
45 degrees.
Eh? Come again? I didn't hear that.
7, 5 is.
Go ahead. Say something again.
I say if it would have been 45 degrees.
No, they want to find the length.
I mean, oh, the length.
The length, man.
Oh!
Let's see if you're thinking. Let's see if you're thinking. I mean, I sent out the trigonometry worksheets in the WhatsApp group that you're in, madam. If you watch the trigonometry videos.
That's the sign and the cosine you question.
Oh, okay. So let's see if you're thinking now. This is a reasoning question. I think it out. They want to find the length piece.
Mm.
What information do you already have?
I have
Where? Come again? Look at it.
Sorry, sir.
I didn't hear that.
I was saying sorry, I never realized I'm reminded on it.
Okay. Well, you can actually draw this to scale, you know. All right, try to draw the scale and see if you can figure it out. You can actually draw to scale. You can actually draw to scale. But take a good look at it though. Take a good look at it. What other thing could we find out by what we know without drawing it to scale?
Sir, the R.
The R? Okay, all right, we can find the R. So what is the R equal to?
Sir, 68.
How much?
68.
Oh, you got 68.
Sir, because you already know that the interior angles in a triangle measures 180. Sir, now add the 82 and the 30 and minus it from 180 to get R.
Okay, now, how much you got for it?
68.
68. All right, good. What else can we find?
Sir, P is kind of obviously at 90 degrees.
P is what?
90.
Yeah, P is 90. So that's obvious right there. So that's already known. What else can we find?
The side there. And
Go ahead, Lexi.
the side of the triangle.
Which part of the side? See if we're on the right side. Which part of the side?
Sir, probably QR would have been 8 centimeters.
The Q down what?
Sir, the line where QR is could be 8 centimeters.
No, can't be. Because these two angles are not equal. Can't be. They have to be equal first. Then that's just an isosceles triangle. What else can we find? We need to find that thing before we can find an NPS.
What else did I find?
Hmm?
More than the length of the
No. We need to find this length right here. That's what we need to find. But we need to know something else before we can find that length. Take a good look at it.
the length from PQ.
No, but no. But if you find line PQ, you have to know something else.
What may I miss?
All right, all right, it's a PS, right? You must find length PS. It's a right angle triangle, first of all. So, how much information do we know about this right angle triangle, of which PS is a part of? What do we know about it?
You only know, sir, it measures 90 degrees and SQ is 8 centimeters.
And what type of line is SQ called? What type of line is SQ called?
Right now, alongside the
No, alongside me.
Hypotenuse?
Hypotenuse. That's correct.
Yes, that. Oh my God.
Octavian sound like what's your name? Octavian sound like, what's your name again?
Who?
Who? McLean, man. McLean's your name, sir?
Sir, Tagini and Taylor
Tagini,
don't
yeah.
sound alike.
Come again, what is it?
They don't sound alike.
They don't sound like? Almost sound like, almost. All right, just talk sound like, I'm free of that. All right, so Makeda, so let's find the adjacent. Well, Makeda, yes, we're supposed to find the adjacent length. But before we can find the adjacent length, we have to have another piece of information which we don't have yet, which we can calculate. All right. I want to take another look at it again. Yes, Makeda, it is a hypotenuse.
So we need an angle.
Ah, the angle. Exactly. So what's the easiest angle we could find? Right there. Easiest angle we can find. So go look at it. Easiest angle you can find. That we need for that triangle. Where would that angle be?
The opposite angle.
So where would that opposite angle be, by the way?
Directly in front of which part? No.
Sir,
Gustavian.
sir, angle we see on the triangle were obvious at the 90.
At the 90?
Yeah.
I mean, this 90 here?
Yes, sir.
But we never use this 90 when using the
Trigonometry.
the trig ratios. That 90 is never.
The triangle here.
Part that.
It
Sir, 30 angle.
Oh, where the 30 is. But the 30 is not the angle. But when you find the angle right here, sister?
so would that be 60 degrees?
Ah. See, I'm using eyes carefully to remember, you know. This word is a secret parallel because
so when if all of the angle them equal.
But remember, you know, the sum of the interior angles between two parallel lines is 180. So if you take 90 from 180, you get 90. So we'll have piece of the next angle. So 30 from the 90 gives 60. That's it, 60 degrees.
But that type of triangle there have three equal sides. It equal to 180.
No.
So it's equal.
No, man. It's a triangle now. If it's a separate, you have to separate it. So this one 90. This one 80. 60, sorry. I know I have 8 centimeters, right? So I asked to find this one. That's why it's adjacent. So you have the hypotenuse, you ask to find the adjacent. So which trig ratio would you use now? No, Makeda. That's the question now. Which trig ratio would you use now? Now that you find the angle now, which trig ratio would you now use?
You have the hypotenuse and you have the
And you ask to find the
adjacent. So I can use cosine.
cosine. That's correct. Right. Use cosine. I remember I said the formulas are actually given on the exam paper, so you have to memorize it. Right? So I use cos, cosine. Right? So cosine would not equal to the adjacent side divided by the hypotenuse, right?
Mhm.
So
So it's
cos of 60 is equal to A
0.5.
over H, A over 8. So what do we do have to find A now? Say they watch the video.
Cross multiply.
Cross multiply. Good. So cos of 80 times 8 will give you the answer for the length of A. So what's the answer?
4 centimeters.
4 centimeter?
Mm-hmm.
That's it again?
Yes, sir.
Let's make sure that.
And let me get, am I alone get that?
Me never yellow with that. I get the check it too.
Cos of 60 at 0.5.
Oh yes, yes. So
You cross multiply with 8 and I get 4.
4. All right, so that's correct. So therefore the answer for this is 4. So you see how much thinking I forgot you? You have to observe that this is a 90-degree beam formation too. Right? You have to work parallel. The two of them parallel must have a 90-degree beam formation too. Right? So you see how much thinking you have to do before you even reach this. All right. Yeah, man, not as easy as it looks, eh? All right. Let's continue. All right. Marks. Length PQ. Length PQ. So find the height, which is 4. Now I find length PQ now. And that's easy. So which trig ratio would I use to find length PQ? Same thing. Well, not the same trig ratio, but you have the information now. So this is 4. Now, do you have to use a trig ratio to find length PQ?
No.
What else could you
You
use to
can
find
use
length PQ?
Pythagoras theorem.
Oh. Oh, may I work well together now? Yeah, I use a brain these days. That's good. Okay. So let's use the Pythagoras theorem then. The Pythagoras theorem, for those who don't remember, a squared plus b squared equal to c squared. And note that this 8 is always a c squared. 8. So if you want to call this a, PSA, no problem. So 16, 4, 16 plus b squared. 8, 64, because c is 8. Minus 16 from 64 is how much? How much that equal to? 16 from 64.
40.
How much?
48.
48. 48. Wow. 48. What's the square? What's the square root of 48? What's the square root of 48? I want to know.
6.9.
How much?
6.9.
6.9. So this is 6.9. All right. No, but we're not out of the woods yet, you know. We're not out of the woods yet. Oh, let's see if we can use the trigger and figure it out here. How about that?
Okay.
It's gonna be opposite over hypotenuse. It's gonna be sine. Sine theta. What? So if you use sine theta, let's say we give a sine 6.9 and we use sine theta. The sine of 60 degrees. We'll try to find the opposite length, OP, over the hypotenuse. So what's the sine of 60?
0.87.
Times 8 is how much?
Is 6.96.
So 0, how much?
No, 6.96. Let me get.
Look at that. Sine of 60. 0.9 approximately, right? Multiply that by 8. 6.9. All right, so yeah. So approximately 6.9. One decimal place you can use. I get 6.9. All right.
But that,
Yeah.
that would not accurate.
Yeah, man. 6.92. One decimal place is 6.9.
6.96.
Yeah, 6.96. 6.92820322303. Where you get it from? You know, use the calculator, right?
Sine of 60, we get 0.86602.
Yeah, multiply all that by 8. How much you get?
By 8.
Oh, okay. Okay. Now, so they want us to find the area now of the entire shape, trapezium. But to find the area of the entire shape, what do we need to know? Well, that question is a real exercise.
The area, it not depend the formula. So.
Yeah, but you know something else before we can find the area.
You need to know the rest of angle then.
No, no. There's an angle now to help you find it.
And the rest of sides.
The other side. You need the next parallel side. Come on, so the trapezium, the formula for trapezium, you know. You have to find the sum of the parallel sides. So you'll have one length of the parallel side, you find the other length. See now? So this is required a thinking. All right, a lot of thinking is required right here. Follow now? Everybody see that?
Yes, sir.
So our students need to understand. The teacher will find here for trapezium, of course. Teacher will use trigonometry, of course. But the teacher can't teach everything. You have to practice to think. You have to use your brain. You have to think. You have to use your eyes and look. You have to learn to use what you know to find out what you don't know. So if I'm in your position, all I need to do is to write down to the corner on a piece of paper what I know about the question. Establish what you know already. What you know is how to find the area of the trapezium. Why? Because you're given that formula. You know how to use the trig ratios. You are given those formula. You know, use Pythagoras theorem. You are given that formula. You know that the sum of interior angles between two parallel lines is 180. You write that down too. So you establish what you know. So even when you practice tomorrow evening, you practice throughout the day, you practice Monday night, and you go to bed Tuesday night. No study Tuesday night, straight to bed. If you study on your own. But I'm just saying to you, any study that studies the Bible, pray. However, in addition to that, when you're practicing, you must practice one, ask yourself questions. Practice to observe, practice to write down what you already know. In English language class, you have learned about a comprehension strategy called KWL, right? What you know, what you want to know, what you learned. How does it apply to mathematics? What you know, what you want to know. KW, what you know, what you want to know. So when I use what you know to find out what you want to know. Simple. Make sense to everybody?
Yes, sir.
Make sense to you? Okay. So in order to find SR, you have to use which formula? Which formula do you use to find SR? If you watch the video, Lexi, Makeda, YouTube, the glass, what
Um, um,
are the formulas do you use? So let me know if you are practicing or not.
um,
Much?
so sign rule.
Sine rule. Excellent. That one there for everybody that know sine rule. So this leg is opposite to that. But you need this, you're gonna need this angle if you use the sine rule. So I have to find this angle so you can use this opposite leg to it, right? So I have to find this angle. And we got the angle earlier from Tavion. What was it again?
68 degrees.
68 degrees. So the sine rule now will help us to find this length. So the sine rule, I say, okay, 8 over the sine of 68 is equal to x, so we're trying to find, over the sine of 82. And then now, cross multiply, so 8, so obviously you're going to find, you multiply 8 times the sine of x, 82. Come again? I didn't hear that. What was that?
So I say my writing the rest of the letter them first. That's it I get me confused for some reason.
You have to do it?
Writing the rest of letters.
Yeah, you could do that. Yeah. You could do that.
Some reason without it, we get confused.
Come again? I didn't hear what you said.
For some reason without it, I get confused.
Without what you get from?
Without filling in the rest of letters.
Letters.
So as in, I don't know if I
Oh man. Remember, say, this 8 have to match up with the angle. But the sine rule work with opposite angles, angles opposite the length.
yes, sir.
So
Yeah, that would have been like the angle would have been like capital R and the 8 centimeter would have been the side.
Yeah. But remember, say I applied it, you already have applied it, so just use the information you know already. So you don't get confused, use the information you know. You understand? Just apply it. Make sense?
Okay.
You have to apply it, right? You have to apply it. You have to apply it. All right. You have to apply it. All right. So basically, we don't have to spend much time on this question anymore because you have the idea That's the point. You have to have the idea. So you have to use cosine rule to find, sorry, sine rule to find SR length. You have to find the angle right here to find the SR length. And then once you do that, you apply the sine rule to find SR length. They apply the formula to find area of trapezium. You get your answer. Basically. Any questions, Lloyd, Tavian, and Francis?
No,
Sir,
sir.
No, sir.
All right. Okay. All right.
so I can just finish the one here. Let me see something.
Oh, all right. All right. We'll finish now. We're gonna get a water on that side now. So may hesitate. So basically finish 2 questions technically. All right. So the sine rule, so it's 8 over the sine of 68. It's equal to x over the sine of 82. So multiply 8 times the sine of 8. The sine of 82, let me know please and tell us the answer. What's that equal to?
Zero point nine.
Everything come to 0.9?
0.99.
Sine,
But
the
that's,
sine of 82 times 8, right?
yes, and then you multiply by 8, you get 7.92.
7.9.
Yes,
All
sir.
right, the 7.9 now must be divided now by the sine of 68. How much?
Um,
Sine of 68. So 79, 7.9 divided by the sine of that.
8.7.
I get 8.5.
Well, let's see,
7.9 divided by the sine of 68. I get
8.52.
8.5. 8.5 Fabian?
Yes, sir. Sir, if we round
I
off
get that.
one place, no, we can't round off. It would have been 8.5.
8.5.
So for my calculator, wanna divide 9.7, 0.9 into 7.9?
No, we just write
So,
7.9. Oh, this is how we use a calculator. Right? 7.9 divided by sine of 68. You never find sine. You just put sine of 68. The answer will come up. 7.9 divided by sine of 68, and you that 8.5. So now we can find the area of it now. Area trapezium A plus B divided by 2 times height.
Right.
All right. So therefore, that now equal to
That is A and B.
6.9. A and B are the 2 parallel sides. 6.9 plus 8.5. 15.4. That's 15.4 divided by 2. And multiply by the 4. Actually, they can multiply by 2 now. That would have been 30.8. No, 12.2 times 2. 15.4 again. Sorry.
So how much I get?
No. 2 into 4, then get 2 times. And then 15.4 times 2, 30.8.
Oh, yeah, let me get.
That's what you get to?
Yes, sir.
Yeah, 30.8. The area of, for those listening on YouTube, the area of the the figure is 30.8. So to run up the session, because I think we need to take a break. Um, take a little break here. We resume tomorrow. I have to cancel a few classes so we can start early. They can get some rest and resume. Okay. So, but it requires a lot of thinking, right? A lot of thinking. As you will not necessarily get the same question on Wednesday, certainly not. But what is important to learn from this exercise is that you have to utilize what you know to determine what you don't know. That is really what the essence of it is about. So we have finished these two questions. Let's see if we can look at the third question. If not, we'll take a break and resume um, tomorrow. This question now is, I'm skipping this one. We'll go to, we'll skip this one too. This has to do with different type of question. So we should be able to look into the measurement question from that year. All right. This question number 6. So you can break here, because I want to sleep. I think you probably want to sleep too. So break here for now, and then we will resume. What time is best for you guys?
No, nobody else in I got church. Kevin, I got church.
So 9 a.m., 10 a.m., 11 a.m., 12 o'clock. What time?
RJ, I got church. Kevin, I got church.
No, but him can start 12.
So we start at 12. All right, so we start at 12. All right. So we're going to finish 2019 paper. Because I guess 2019 paper is the best paper to teach from. And then we'll run through some multiple choice questions on the night, if anything. And you'll sleep on Tuesday night. Right? So we'll start back tomorrow at question number 6. You can go through it yourself first if you wish. Then we'll do statistics question afterwards. Question number 5. Then we'll go to
Sure,
that.
the question the way you just show with that I got that company something.
Which one now?
The skill, one of the skill. The
Well,
map something.
I don't know. May or may
Yes, that topic.
not. I don't know. But the thing about it is that what I'm saying with this particular exam paper, it takes in some more of what you should know. So I guess let's say God allows us to choose the right one. All right. So as we wrap up tonight, I just want to pray before we close, and then tomorrow we come in. But before I go any further, this is our tradition to find out from those students. So I want to say thanks to Lexi to invite your friends over to our maths cookout. All right. So we started from 9 and we basically went 3 hours and a half, nearly 4 hours of thing. You must get some rest, which is very important. All right. All work and no rest will also make Jack and Jill a dull boy and girl. All right. But as in tradition, we always ask, how was the session tonight? So let's start off with how you pronounce your first name, Francisco? Fran. Oh, tell me your full name. Go ahead. You pronounce your full name for me, please. Unmute your mic and tell us your full name. That's Taria Francisco. Francis. Could you pronounce the name for me, please? I know you're hearing me. All right. While we get in, while that mic is sorted out, let's start with Lloyd. How was your session tonight, Lloyd? I'm not hearing you. Go ahead.
Session. I learned a lot, especially recircle theorem and how to go about answering the question.
Okay. All right. Good. Thank you for that. Tavian.
Sir, the session was good and I refreshed my memory on vectors.
Refresh your memory, huh?
On vectors.
Vectors. All right. Good. All right. What about the next person? The name that I'm trying to pronounce. Person probably gone to bed already. All right. Next.
Drop asleep.
Go ahead, Lexi.
Share all my feedback too.
Yeah, could give me a feedback.
So the session was okay. So
Go ahead.
well, I learned a much better approach to circle theorem when I make it seem all that hard and frightening as before.
Okay. All right, good. And what you guys could do is you could practice the method, and some persons have already worked out some past paper already. So probably you could do is just pick up past paper, try to do circle theorem, and then look for the video that the person went through for circle that particular year, and of course you will be able to see if what you came up with is what they came up with, and you know if your answer is right or wrong. You have to think. All right. Um, good. So we don't know about our good friend there in terms of getting the feedback from them, but I must say thanks to you all for really joining me and joining us, I should say, tonight. Last year we got 50% pass on maths. The aim is that we get more this time. Well, I don't really hope. Next year, you have to really champion the cause this year and ensure that you capitalize on this additional opportunity. I hope you have been practicing because practice is really important as we go through the rest of this paper, especially in measurement. I think I want to spend some time. I'm going to do a special thing for measurement in terms of showing you how to go about answering measurement questions as well, so we can capitalize. Now, here's a little secret. You need to ensure that you fully understand statistics, that you want to get the full marks for statistics. You want to get the full marks for statistics. Algebra, you need to ensure that you're ready for algebra. Okay, you want to get the full marks for algebra as well. I've showed you a technique you can use for algebra in terms of, and you could use for simultaneous equation, even though, all right, so I see Lexi said it was good. Sorry, I mean, Makeda said the class was good. Thank you for your feedback, Makeda. All right. Good. Now, there's a technique you can use the same matrix method in the regular algebra question section of the exam to find simultaneous equations. Right? Don't have to try to remember the elimination method. That's not necessary. And of course, I told you about the trial and error method that you can also use for simultaneous equation. You also need to master inequalities, and of course, well, that would come under functions and relations. So once you can master a few of these areas, then without a doubt, you should pass your exams. You only need to get 3 questions marked in full marks to get it to pass the exam. And of course, try to maximize your effort on the paper 1. All right. So without any further ado, we're just going to pray and close off this session and get some rest. And I ask that you pray for me. I don't know. So happens that whenever it's time for exam here, that old rascal called the devil tries to get my mind on the wrong frame of mind. But to God be the glory, great things He has done. So let us pray. Loving Father, we give you thanks for being the God you are to us. Father who art in heaven, Hallowed be your name. Father, we have asked for a productive session. You have given us a productive session. At this moment, we will sleep now and ask that as we go to our bed, may you activate our guardian angels to protect us, to watch over us. And as these students sleep, dear Father, Lord, I know what you have done for Dr. Benjamin Carson when he was preparing for his chemistry exam and he knew not what to do. But you, oh God, taught him in his dream. You gave him a session in his dream. And as he was taught in the dream, when he went in the exam room, he was able to remember everything I've taught him. And he became a successful doctor as he is today. And so, Father, I pray the same for each and every student who has been a part of the Zoom session. All the students are in CDPLABS services, Holy Trinity High School, and across Jamaica and the Caribbean. May, as they go to bed tonight, Jehovah God, you will teach them that lesson tonight and prepare them for this exam. Lord, I am waiting for the testimony, waiting to hear that you taught them as they sleep each night and prepare them for the exam. It's not about us, it's about you. So, Lord, as we pray, you said faith without work is dead. And so, Lord, we're here working and we're depending upon you. So we pray that you will bring life and success to these students. In the name of Jesus Christ, we pray. So have yourselves a good night. Take care. See you tomorrow. Pray for me. So that whenever it's time.
I love you, Lord. Oh, your mercy never fails me. And all my days I've been held in your hand. From the moment that I wake up until I lay my head, oh, I will sing of the goodness of God. 'Cause all my life you have been faithful, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. I love your voice. You will lead me through the fire, and in darkest night, you were close like no other. I've known you as a father, I've known you as a friend, and I have lived in the goodness of God. Yeah. all my life you have been faithful. And all my life you have been so, so good. With every breath that I am able, oh, I'm gonna sing of the goodness of God. I'm gonna sing, I'm gonna sing. Oh, 'cause all my life you have been faithful. And all my life you have been so, so good. With every breath that I am able, oh, I'm gonna sing of the goodness of God. Oh, I'm gonna sing of the goodness of God. With every breath, over all my days.
All right, good night to those persons who will be coming on tomorrow, tonight on our YouTube channel. We resume our marathon session at 12 p.m. tomorrow, Sunday, May 29th. So, all the best, take care of yourselves. I am Ronnie Bernard, your host for this session. I'll see you tomorrow, God's will. Take care.